I want to talk to you about something kind of big. We'll start here. 65 million years ago, the dinosaurs had a bad day. A chunk of rock 6 miles across, moving something like 50 times the speed of a rifle bullet, slammed into the earth. It released its energy all at once. And it was an explosion that was mind-numbing. If you took every nuclear weapon ever built at the height of the Cold War, lumped them together, and blew them up at the same time, that would be 1/1,000,000th of the energy released at that moment. The dinosaurs had a really bad day. Okay? Now, 6 Mile wide rock is very large. We all live here in Boulder. If you look out your window and you can see Long's Peak, you're probably familiar with it. Now, scoop up Long's Peak and put it out in space. Take Mount Meeker, lump that in there and put that in space as well. And Mount Everest, and K2, and the Indian Peaks. And you're starting to get an idea of how much rock we're talking about, okay? We know it was that big because of the impact it had and the crater it left. It hit in what we now know as Yucatan, the Gulf of Mexico. You can see here, there's the Yucatan Peninsula, if you recognize Cozumel off the east coast there. Here is how big of a crater was left. It was huge. To give you a sense of the scale, okay, there you go. The scale here is 50 miles on top, 100 kilometers on the bottom. This thing was 300 kilometers across, 200 miles. An enormous crater that excavated out vast amounts of earth that splashed around the globe and set fires all over the planet, threw up enough dust to block out the sun. It wiped out 75% of all species on Earth. Now, not all asteroids are that big. Some of them are smaller. Here is one that came in over the United States in October of 1992. It came in on a Friday night. Why is that important? Because back then, video cameras were just starting to become popular, and people would bring them, parents would bring them, to their kids' football games to film their kids playing football. And since this came in on a Friday, they were able to get this great footage of this thing breaking up as it came in over West Virginia, Maryland, Pennsylvania, New Jersey, until it did that to a car in New York. Now, this is not a 200-mile wide crater, but then again, you can see the rock, which is sitting right here, about the size of a football, that hit that car and did that damage. Now, this thing was probably about the size of a school bus when it first came in. It broke up through atmospheric pressure, it crumbled, and then the pieces fell apart and then did some damage. Now, you wouldn't want that falling on your foot or your head, because it would do that to it. That would be bad, but it won't wipe out, all life on Earth, so that's fine. But it turns out you don't need something 6 miles across to do a lot of damage. There is a median point between tiny rock and gigantic rock. And in fact, if any of you have ever been to near Winslow, Arizona, there is a crater in the desert there that is so iconic that it is actually called Meteor Crater. To give you a sense of scale, this is about 1 mile wide. If you look up at the top, that's a parking lot, and those are recreational vehicles right there. So it's about 1 mile across, 600 feet deep. The object that formed this was probably about 30 to 50 yards across, so roughly the size of Mackey Auditorium here. It came in at speeds that were tremendous, slammed into the ground, blew up, and exploded with the energy of roughly a 20-megaton nuclear bomb, a very hefty bomb. This was 50,000 years ago, so it may have wiped out a few buffalo or antelope or something like that out in the desert, but it probably would not have caused global devastation. It turns out that these things don't have to hit the ground to do a lot of damage. Now, in 1908, over Siberia, near the Tunguska region, for those of you who are Dan Aykroyd fans and saw Ghostbusters when he talked about the greatest cross-dimensional rift since the Siberia blast in 1909, where he got the date wrong, but that's okay. It was 1908, that's fine, I can live with that. Another rock came into the Earth's atmosphere, and this one blew up above the ground, several miles up above the surface of the Earth. The heat from the explosion set fire to the forest below it. And then the shock wave came down and knocked down trees for hundreds of square miles, okay? This did a huge amount of damage. And again, this was a rock probably roughly the size of this auditorium that we're sitting in. In Meteor Crater, it was made of metal, and metal is much tougher, so it made it to the ground. The one over Tunguska was probably made of rock, and it's much more crumbly, so it blew up in the air. Either way, these are tremendous explosions, 20 megatons. Now, when these things blow up, they're not going to do global ecological damage. They're not going to do something like the dinosaur killer did. They're just not big enough. But they will do global economic damage because they don't have to hit necessarily to do this kind of damage. They don't have to have global devastation. If one of these things were to hit pretty much anywhere, it would cause a panic. But if it came over a city, an important city, not that any city is more important than others, but some of them we depend on them more on the global economic basis, that could do a huge amount of damage to us as a civilization. So, now that I've scared the crap out of you, what can we do about this? All right, this is a potential threat. Let me note that we have not had a giant impact like the dinosaur killer for 65 million years. They're very rare. The smaller ones happen more often, but probably on the order of a millennium, every few centuries or every few thousand years. But it's still something to be aware of. Well, what do we do about them? The first thing we have to do is find them. This is an image of an asteroid that passed us in 2009. It's right here. But you can see that it's extremely faint. I don't even know if you can see that in the back row. These are just stars. This is a rock that was about 30 yards across, so roughly the size of the ones that blew up over Tunguska and hit Arizona 50,000 years ago. These things are faint. They're hard to see, and the sky is really big. We have to find these things first. Well, the good news is we're looking for them. NASA has devoted money to this. The National Science Foundation, other countries are very interested in doing this. We're building telescopes that are looking for the threat. That's a great first step. But what's the second step? The second step is that we see one headed toward us, we have to stop it. What do? You've probably heard about the asteroid Apophis. If you haven't yet, you will. If you've heard about the Mayan 2012 apocalypse, you're going to hear about Apophis because you're keyed into all the doomsday networks anyway. Apophis is an asteroid. It was discovered in 2004. It's roughly 250 yards across, so it's pretty big size, bigger than a football stadium. And it's going to pass by the Earth in April of 2029, and it's going to pass us so close that it's actually going to come underneath our weather satellites. The Earth's gravity is going to bend the orbit of this thing so much that if it's just right, if it passes through this region of space, this kidney bean-shaped region called a keyhole, the Earth's gravity will bend it just enough that 7 years later, on April 13th, which is a Friday, I'll note, in the year 2036, you can't plan that kind of stuff, Apophis is going to hit us. And it's 250 meters across. So it would do unbelievable damage. Now the good news is that the odds of it actually passing through this keyhole and hitting us the next go round are 1 in a million, roughly. Very, very low odds. So I personally am not lying awake at night worrying about this at all. I don't think Apophis is a problem. In fact, Apophis is a blessing in disguise because it woke us up to the dangers of these things. This thing was discovered just a few years ago and could hit us a few years from now. It won't, but it gives us a chance to study these kinds of asteroids. We didn't really necessarily understand these keyholes, and now we do, and it turns out that's really important. Because how do you stop an asteroid like this? Well, let me ask you, what happens if you're standing on the road and a car's headed for you? What do? You do this, right? Boom, the car goes past you. And we can't move the Earth, at least not easily, but we can move a small asteroid. And it turns out we've even done it. In the year 2005, NASA launched a probe called Deep Impact, which slammed a piece of itself into the nucleus of a comet. Comets are very much like asteroids. The purpose wasn't to push it out of the way. The purpose was to make a crater, to excavate the material and see what was underneath the surface of this comet, which we learned quite a bit about. We did move the comet a little tiny bit. Not very much, but that wasn't the point. However, think about this. This thing is orbiting the sun at 10 miles per second, 20 miles per second. We shot a space probe at it and hit it. Okay, imagine how hard that must be, and we did it. That means we can do it again. If we see an asteroid that's coming toward us and it's headed right for us and we have 2 years to go, boom, we hit it. You could try to, if you watch the movies, you might think about, why don't we use a nuclear weapon? It's like, well, you can try that, but the problem is timing. You shoot a nuclear weapon at this thing, you have to blow it up within a few milliseconds of tolerance, or else you'll just miss it. And there are a lot of other problems with that. It's very hard to do. But just hitting something, that's pretty easy. I think even NASA can do that, and they proved that they can. The problem is, what happens if you hit this asteroid, you've changed the orbit, you measure the orbit, and then you find out, oh yeah, we just pushed it into a keyhole, and now it's going to hit us in 3 years. Well, my opinion is, fine, okay? It's not hitting us in 6 months, that's good. Now we have 3 years to do something else. And you could hit it again, that's kind of ham-fisted. You might just push it into a third keyhole or whatever. So you don't do that. And this is the part, it's the part I just love. After the big macho, bam, we're going to hit this thing in the face, then we bring in the velvet gloves. There's a group of scientists and engineers and astronauts, and they call themselves the B612 Foundation. For those of you who've read The Little Prince, you understand that reference, I hope. Little Prince who lived on an asteroid, it was called B612. These are smart guys, men and women. Astronauts, like I said, engineers. Rusty Schweikart, who was an Apollo 9 astronaut, is on this. Dan Durda, my friend who made this image, works here at Southwest Research Institute in Boulder on Walnut Street. And he created this image for this, and he's actually one of the astronomers who works for them. If we see an asteroid that's going to hit the Earth, and we have enough time, we can hit it to move it into a better orbit. But then what we do is we launch a probe that has to weigh a ton or two. It doesn't have to be huge, a couple of tons, not that big. And you park it near the asteroid. You don't land on it, because these things are tumbling end over end. It's very hard to land on them. Instead, you get near it. The gravity of the asteroid pulls on the probe, and the probe has a couple of tons of mass. It has a little tiny bit of gravity, but it's enough that it can pull the asteroid. And you have your rocket set up so that you can barely see it here, but there's rocket plumes, and these guys are connected by their own gravity. And if you move the probe very slowly, very, very gently, you can very easily finesse that rock into a safe orbit. You could even put it in orbit around the Earth where we could mine it, although that's a whole other thing. I won't go into that. But we'd be rich. So think about this, right? There are these giant rocks flying out there, and they're hitting us, and they're doing damage to us. But we figured out how to do this, and all the pieces are in place to do this. We have astronomers with telescopes looking for them. We have smart people, very, very smart people, who are concerned about this and figuring out how to fix the problem. And we have the technology to do this. This probe actually can't use chemical rockets. Chemical rockets provide too much thrust, too much push. The probe would just shoot away. We invented something called an ion drive, which is a very, very, very low thrust engine. It generates the force a piece of paper would have on your hand. Incredibly light, but it can run for months and years, providing that very gentle push. If anybody here is a fan of the original Star Trek, they ran across an alien ship that had an ion drive, and Spock said they're very technically sophisticated. They're 100 years ahead of us with this drive. Yeah, we have an ion drive now. We don't have the Enterprise, we got an ion drive now. Spock. So that's the difference. That's the difference between us and the dinosaurs. This happened to them. It doesn't have to happen to us. The difference between the dinosaurs and us is that we have a space program and we can vote. And so we can change our future. We have the ability to change our future. 65 million years from now, we don't have to have our bones collecting dust in a museum. Thank you very much.